In the previous video, we looked at how Xcode's address sanitizer can reveal details about Clang-based memory issues. In this video, we're going to look at different types of assertions, and particularly the assert method. In some situations, it is simply not possible for our application to continue functioning if a particular condition is not satisfied. Assertions are a handy debugging tool that allow us to make sure that our essential conditions are satisfied before continuing execution. If our asserted condition evaluates to true, our application runs as expected. Otherwise, our application is terminated. Assert is only evaluated in debug mode. So if an assertion is put into production, it will never be evaluated. We'll make sure to demonstrate this later. Let's start by creating a new Xcode project. We'll name it Error Handling and click Create. We'll open up our viewcontroller.swift file and write a simple assertion in our view.did_load to see how it acts. We'll start with the keyword assert and pass in a Boolean for our condition, along with a useful error message to be displayed. If we build and run our application, we'll get an assertion failed message in our LLDB console. And we see assertion failed, the condition was false. Now let's use assert in a more realistic manner. Asserts are really helpful when building portions of our applications where we may be uncertain whether valid data is being passed in or not. Let's create a new function that takes an array of integers. This function will take the input array and run a reduce function that sums all the values before returning. Build and run the application, and we see it runs without a problem. What if this data was crucial to the user's experience, but not to the overall functionality of the application? This solution, however simplistic, demonstrates a common use case for an assert. Let's now modify our function to employ an assertion. We'll once again call the global assert function that must be met in order for our application to operate as expected. We'll pass in an error message to be displayed to the developer. Let's build and run our application again, and this time we get an assertion failed. This is precisely what we want. As mentioned previously, assertions are only evaluated in debug mode. To demonstrate this, click on the root application followed by Build Settings. Under the Swift compiler section, simply switch the debug value to fast and rerun the application. As expected, our assertion never fires. The Swift standard library offers 4 more global assertion functions that differ from each other in how they affect the flow of our code. We just saw assert, which is a C-style assert that allows us to do sanity checks while actively developing and testing. Next is assertion failure, which we can use to indicate that a check has failed or to halt execution when control flow reaches undesired code. Precondition is much like assert in that it checks a necessary condition before making forward progress in the app. More on this in a moment. Precondition failure indicates that a precondition was not satisfied by terminating execution. And fatal error, which unconditionally stops execution and prints a message to the console. You may have noticed that precondition is much like assert. One big difference, however, is that assert is designed for sanity checks during development or testing, while precondition is for guarding against things that, if they occur during the application's lifecycle, would mean that the program can no longer proceed as expected. Another big difference between assert and precondition is that precondition will get evaluated in production. Of course, I'll have some more information about these different assertions on this video's resource page. In this video, we have seen how we can assert conditions to be true, causing catastrophic failure if the condition is false. In the next video, we'll look at error handling in depth.